Problem number 16 is a question that a lot of people have asked about. Once again, a lot of it's a matter of interpreting the information. So it tells you the diameter of each consecutive concentric circle is 2 feet longer than the previous one. The innermost circle has a diameter of 2. So you can think of it 2 feet, then what's the next one? 2 more than that, and then the last one, 6 feet. Okay, so there's kind of just the labeling of this information. And you want to find the probability of randomly choosing a point that falls in the shaded region of this diagram. Okay, so our probability is the desired outcome over the total possible ones. So our desired outcome is the shaded region. And the total is just all regions. And so when you're looking at this, all the regions, the shaded and unshaded combined, is simply the large circle, right? This outer circle with the diameter of 6. So what I can do is I can put that area formula in right here, because what is the radius of this large outer circle? If the diameter was 6, the radius is 3. Okay, so I'm looking at 9 pi. Okay, 3 squared is 9. So there's my denominator. That's the total sum of all the shaded and unshaded regions. Now I want to find the shaded region. Okay, so the shaded region has to be built up because it's 2 separate pieces. The shaded region is this outer ring, right, plus the circle in the middle. Okay, so the outer ring has an area formula of a band, which is pi r squared minus pi small r squared. And then this small circle inside, pi r squared. But again, because this is, I'm going to call this subscript 3 here, because it's a different radius. It's not the same. So all 3 of these will have different radii. Okay, but let's look at this shaded region here. So what was the radius of the whole outer, this capital R? Was again 3. And then minus here, this white circle has a radius of what? 2. Okay, so we're looking at 9 pi minus 4 pi. And then what about this small inner circle? It has a radius of 1. So pi times 1 squared. So we're adding pi. So here's our total shaded region. 9 minus 4, which is 5, plus 1, which is 6 pi. So again, we have that whole 9 pi minus 4 pi, and then adding the small circle back into it. And so when we reduce our fraction, the pi's cancel. What goes into both 6 and 9? 3 goes into 6 twice, 3 goes into 9, 3. So you're looking at 2/3.